What's up, everybody? Today we'll talk about the MATLAB implementation, and look at this. Wow, that's like very fast, right? And let me just make point 1 second. Yeah, that's reasonable. You see that was DFS, right? Because it doesn't search like layer by layer. It tries to improve on the depth for some reason, right? And by the way, let me explain this. First open the figure, right? And then wait 2 seconds. And you're like, why would you want to wait? And because when I press run, since I have 2 monitors, right, it appears on the other monitor, and that's like my hack around that issue. And okay, so by the way, do you remember? Do you remember this matrix? This was the matrix that we talk about on the problem. And however, if you like to see maybe a little more cool thing, right? Let's do that. And for that one, I will, I guess, comment out that pause. Let me run that. All right. Okay. That was good, right? Right. By the way, just so we have some connection between a real connection between start and end node, I just hard coded that such that this part and entries in that, right, are 0. So there's a space. It's not like, hey, there's no solution, there is no path from S to E, right? And okay, that was the case. So by the way, before that, let me go through each function. Okay, by the way, just do not consider, you can delete that, hopefully I will have some means to share that with you guys. Okay, notice, let's consider that you have created node list, and it is a list or it's an array where you have nodes in that, right? Node 1, node 2, node 16, right? Or node 100, depends on your dimensions. And row and column numbers, are, yeah, I mean, just look at the name, right? Give me row and column, and I will give you the ID of that node, right? Give me row and column, right? And I will, an xid, by the way, xid, and I will give you the ID number. And this code, which I comment out, and I use the I guess you would call it advanced or more improved version, right? I give xid matrix, and it finds xid number, right? However, you don't necessarily need xid matrix for that. By again, node list is all the information that you'll need, right? If you have node list, you can recover, or you can calculate, compute xid matrix, x matrix. You can compute everything from that. This has all the information, right? And however, and since we are going to use that type of functions, like there are like 6 of them, you don't need to recalculate xid, right, for 1,000 times. You don't need that. You can just supply that, right? Yeah, it looks, it kind of looks better to have, smaller number of arguments when you write your function, right? For example, let's consider a function where you have like 10 or maybe 20 arguments, right? That would be kind of confusing, and I agree with that. However, for that case, just that's okay. That's okay. All right. And however, why I'm talking about this? I'm talking about because in the first implementation I made this, and for 10 by 10 or maybe 15 by 15, that was like really annoyingly slow. So that's the case. All right, let's talk about the second function, id to row. So give me id, and I will give you the location, row and column numbers, right? Okay. And here, this is literally what I written on the paper, right? This is literally what I written on the paper. Let's, by the way, check this again. Here, if I have the xid matrix, I will just check the id of that from using that matrix, right? Just it's like very simple. And let's look at id to row call function. Give me id number, and again here we have the id number, for example, for 6, and it will just generate the location. I don't need to say return. Why I did that, I don't know. Anyway, okay, what is the next one? I'm looking at this, and let's look at find neighbor ID, right? It may look like, hey, this is like more than 10 lines, but it's very simple. So neighbor ID is this, and again we have xid and not list, right? Give me id, and I will give you the neighbor IDs, right? Maybe I should do that just to be able to explain it better. For example, give me 7, and I will give you an array where only, but I mean only the numbers, only the number 3, number 6, number 8, and number 11, right? Not the node 11, node, right? Just the numbers, right? Okay. And all right, so it just looks at the row and column. It looks at the dimension of xid or our map, right? And it uses id to row column, right? And we have id, and what I need is that generate row and column, or the location of that id. First of all, you give me some id, and I like to know where is this node you want me to find the neighbors of, right? So okay, and I find that, right, using that function. And the neighbors, again, here, let's look at this, right? How would you know, when you have the row and column information, you would, for example, decrement row by 1, increment row by 1, right? Decrement column by 1 and increment column by 1, right? You would just do that. Just one little details. If you are on the edge of the map, right? For example, you would generate, for example, this is row number 3 and this is row number 1, right? And if you decrement column by 1, what you would get? You would get column number 0, and it is not acceptable, right? And also, for example, here you have the dimension of the problem is 4 by 4, right? Okay, if you increment the column number for that node, right, you would get column number 5. However, the dimension of the problem is 4 by 4, so it is not, it doesn't make sense, right? So you just look at the values, right? For example, here if right, for let's iterate all the locations, and if, for example, the row that you determine is not in that box, for example, is not, for example, greater than 0, right, or is not less than or equal to the maximum row number. And also, again, same goes for the column number, right? You would just delete that. You wouldn't consider that, right? Okay, that's we just did that for that, right? And all right, and out is the, just let me explain that. Out is the, for example, let's say you have two neighbors, right? Row 1, column 1, and row 2 and column 2. Out is like this. Out is like this, right? I mean, it will be a matrix 2 by 2, by the way. However, it will be more efficient to, rather than the rotation, right? Output in the rotation, you can just tell me ID number 1, right? And ID number 2. So here, what do I need? I need something that will allow me to compute ID by using location. So, I mean, this is in the name, right? We just have that. We have that function, and it literally does that. All right. For the first time, I mean, even for that thing, for the first time, when you look at it, it doesn't make sense, and I 100%. There are some things it may looks like, hey, it doesn't make sense. I don't get it. Or when use it for, especially for your problem, it will really make sense. And let's check the map plot, right here. All right, this is like, this looks a little long, or it is not actually, right? Okay, plot the map for a given node list. First of all, find the dimension, all right, and create a matrix. By the way, this tries to, for example, this is one of the things that I can improve, I guess, right? Here, this tries to generate X matrix. You remember what X matrix was? Let me go back here. This is X matrix, right? Meaning it has only zeros, ones, and 1, 5, and 1, 3, right? Okay. It really does that. All right. And then after doing that, it just plots that, right? And then we have node IDs to be plotted. Now this is like a really good naming convention. So, and we have a list of IDs where we like to highlight them by using some red circle or something, right? And okay, so what do? You would, for example, add the types of the nodes on the image, right? It does that. Text, I mean, after using that, you can use text to, for example, put one, just text, put the number 1 on a location, which you specify, right? Which you specify X and Y location, and in that location you would use, for example, just number 1, and that's why I use num to string, right? Number to string, right? For example, let's say this is the type 5 for the first node, and 5, this is 5, and here this is string 5, and here put string number 5 in that location, right? The location of that node. Okay, this is it, right? This is just for the fanciness, right? And you can delete that, by the way. Anyway, so this part is not 100% needed. Anyway, I'm looking at this, and this is the ID array, and for each ID we need to put a red dot, right? So you can use ID to row column, ID to location. I could call that, by the way. Anyway, ID to location function, and to generate the row and column number of that given of that, for example, each ID, right? And you would just indicate some red dot on that location, right? So MATLAB is like the highest lines of, biggest number of codes, right? Not number of lines. So all right, generate children and give me a node and I will give you the children. All right, node ID, you give me node ID and I will give you node ID, neighbor node IDs, and there is a function for that. Just give me an ID and I will give you the IDs of that, right? Okay. However, this gen children, it doesn't give you ID, it gives you the nodes itself, right? So you can just iterate over that and construct that the array called new, and in that array we have the nodes, right? Let's check this. For example, for 6 you would have node 2, not the number 2, node 2, node 5, node 7, and node 10, right? Okay. All right. So this is it, and let's look at the this is the final, this is the final function, right? After that we talk about the main script and filter out. Okay, what do you want to filter out? Filter out the previous search nodes, right? By the way, you can totally do that. Maybe you're like, hey, is this even a thing? You can do that. Yeah, this is an array, right? And each array, each element in that array is a object or a struct, right? And you can recover that struct and get that indicated field and get its value, right? Get its value. All right. So if you have some array where there are structs or nodes in that array, and if you like to iterate over that field, if you like to focus on that field of each node, you can just type that type of syntax. All right. So filter out if search. For that, I generally specify a new variable, empty array, and iterate over that array we have, right? And only get the ones, only get the nodes whose search field is false, meaning we haven't searched them before previously, right? Okay. And also we have new 2, right? We filter out the search ones, and also we like to filter out the wall nodes, right? And that's why, for example, in the previous stage we check the search field, and in that stage we'll check the type, right? What I'm trying to say is this: check the type. If it is not wall, include that, right? Okay. And that's it, right? That's it. And let's check the script. For example, by the way, this is like the problem we consider on the paper, and this is a little bit bigger problem, and this is for just random maze generation. So let's do that. Let's save it. Let's clear all, right? Okay, we again, as in the paper, as in the previous video where we talk about that, right? Just give me X matrix, and you know the structure of the X. Start, 5 for start, 3 for end, 1 for wall, 0 for space, right? Okay. And here x2, by the way, you could have totally written a function for that as well. Give me x, just give me this, and I will give you xid matrix, right? For example, let's not do that. Let's not do that, right? Just run that. And also, by the way, here 16, right? First you vectorize it here, you vectorize that x, you vectorize it, right? And then get the length of it, of that vector, right? And that's how you can just get the number of entries in a given matrix, number of nodes, right? Number of nodes. And here reshape. I mean, reshape is one of the functions where use regularly. However, you whenever you use it, you forget it. So you all the time you find yourself type in dog reshape. And most of the time, to be honest with you, I don't even recall the name correctly, right? I recall shape and MATLAB gives me an error. It says, hey, are you talking about the reshape, man? And like, yeah. So, all right, just give me, just, what? Okay. Right. Just give me an array like this. Okay, just if my space a little bit larger, it would able to compute that array, right? Just a row vector, right? And here, this is the row number and column number, right? I mean, syntax is not that important. Just look at that, right? Just reshape is, you know, one of those things. No one knows, remembers the syntax, but everybody uses it, and everybody checks the documentation page, and everybody just puts some transpose, just change some arguments and stuff, row and column arguments, then, and they would get what they want, right? All right. By the way, this is like for the node objects fields, right? Here, ID, depth, parent. Here, parent node, right? Search, location, and type. All right. This is not rock, paper, scissors or something. This is space rec, start, and end. Okay. Here, this is for the example. For example, I written this, and this is for this node list, and this is for example, node 1, right? Here we can see that, and depth 0. Again, I just highlighted 2 fields where we only need to enter them correctly, and other ones we can just use those values, right? Just those values, and we will change that too. We will change that too. By the way, let me. Anyway, we'll see, right? We'll see. So node list, again, an empty array, and we are going to populate that, right? And again, the same structure, right? We will have 16, right? We will have 16. Let's look at that, and let's look at that. All right. Here again, like in the paper, right? Node.id is that iteration index, and here these are same, and this is same for each node. And since we have the ID or I iteration index, since we have the ID, just give me the location, find me the location. And here, remember, that is exactly what we written. By the way, there is, I guess, you could write ID to local function for that. Anyway, this is right. I'm not mistaken, right? Yeah, this is like one line. You don't need to even make a function for that. All right. So you fill out the location fields, and yeah, in each iteration you add the node to the node list. So update the type fields of each node in node list, right? Okay, there are 4 types: 5, 3, 1, and 0, right? That's perfect. And I'm looking at this here. Okay, what is x? X is this. All right. What is that? Right. This is that where x equals 1, or the entry of that x equals 1, make it true, if not false, right? All right. And let me make that, by the way, run that. Right. You are, wait a sec. I should write that. Yeah. And you are like, what is this? And it is, okay, let me explain. Just row number 2 and 2, right? 2, 2. Row number 2 and column number 2, and this is, right, 1. This entry. Row number 3, column number 2, right? Row number 3 and column number 2, right? Okay, and this again 1 and 2 and 3, 2 and 1, 2, 3, right? This one, okay. So this is it. And what do we want? We want to update the type as 1, right? Okay, just since we have the row and column information, meaning since we have the location, we can get the ID, right? We can, here, this is like all expression is for ID, right? Get the ID of that node and update the type as 1, right? And the same structure we employ for, by the way, I'm looking at this. No, it's like correct. Okay, same structure for 5. However, since there is only 1 5, it will only give us like 1 row and 1 column number. And again here for the same thing, right? Okay. So initialization, like in the documentation, we in the previous video or video before that, I guess. All right, and I written the exact same thing, right, in the comments, by the way. In step 1, right, define 2 sets called open and close. All right, like empty, right? Okay. In step 2, update the depth, parent, and search fields of S node. Okay, and here this is like the case, and we know the ID is 1, right? We know we can reach node S by using that type of expression, right? All right, in step 3, add S to the open set, right? Here this is like the pseudocode version. Just add S, and by the way, open is like empty, so after that process, open will only have 1 node in it, right? All right, and while through the infinite loop, right? And I made this for debugging. Okay, this is again in the documentation. Just get the first entry, or I shouldn't say entry. I first get the first struct element in that open set and call it n, right? And after that, okay, check if we reach the goal, right? Okay, how would you check that? And you would look at the type. If the type is 3, which would correspond to end, right? Okay, and you're like, hey, I solved that. All right, as continue, right? Okay, step 1, generate children. Here, this is the generate children function. Give me some node, and I will give you an array where there are the children generated from that node, right? Okay, so filter out is that. Again, give me some list of nodes, right? And I will filter out the ones that you searched before, and the nodes that will correspond to wall, right? Okay, wall here. Step 3, update the parent field of each node in new, right? And here I exactly written like I written in the documentation, right? You would update that. Okay, that's perfect. Delete n from open. And by the way, numel, I mean, if you have some array or list or something, right, or vector, however, if in that vector as elements you have instead of numbers, you have abstract or maybe more complicated objects, right? MATLAB would kind of like you to use that instead of length, right? So, and since open is a set where we have nodes and objects which we define in it, right? It will kind of make sense to use that. However, you can just change that or translate in your mind as length. Okay. So, all right. Here just says delete and from open. And this is like, yeah. I written this because I thought maybe if we have only one entry, that will kind of, I didn't get an error for that. I just written from my instinct, right? I thought maybe it would give me an error if I only have one. Usually you would do that, right? Okay. And then step 5, update or add that n, node n, to our close set. And we are looking at this, and this is like step 5. After step 6 in the next step, and there will be 9 steps, I guess, right? Okay. And just update the depth field here. By the way, this is exactly how we talk about on the paper, right? On the paper tutorial, right? And step 7, update the search. Update the search, and okay, and update it. All right. However, you know what? I feel like it would make more pedagogically sense to write that. Well, just give me 1 sec, right? I remember. I very clearly remember this section, right? Let me write this. Let me get that up. Wait a sec. Update node list. That would make better sense, I feel like, right? I mean, it would, of course, it's like a little the same. And however, that is more pedagogically accurate, I feel like. I don't know if you agree with that. Just update the node list, right? Right. Because to be honest with you, this is the part that I gave lots of thoughts on it, right? So anyway, some things. Wait. What? Really? Anyway, it doesn't say like there's an error. Anyway, some things don't make sense. So okay, you just get used to them. Anyway, step 8, right? Step 8. And step 8. By the way, this is only the ID, right? This is just, for example, I am going to add the new nodes to our open, and before doing that, just update the node list. Okay, all right. And yeah, I mean, you should kind of persuade yourself into thinking that yeah, that totally makes sense. Anyway, step 8, right? And open and then new. If you append in that fashion, that would correspond to BFS, right? Or if you append in that fashion, new and then open, right? It would be BFS. For example, if I write this and this, if I change, literally just change that, it would give me the BFS result. Okay. All right. Let's look at first BFS and then DFS, or vice versa, right? Step 9, check if open is empty. Yeah, in that stage, if our open set is empty, that will make, that will indicate that, hey, there's no path. What are you doing, man? It's like, right? And break. Okay. And plot close set, right? Okay. Node ID, right? Okay. Just for the debugging and for the visual purposes, I wanted to, in each iteration, I wanted to kind of visualize the map, right? And that's why we use map plot, right? And just highlight the nodes where that are located in close set, right? Okay, here we have close set, and just give me ID numbers of that. Okay, and here using map plot and draw now, and this is common. Draw now and then pause is like if you are, for example, making a simulation and in each step you like to update the graph, right? Maybe you are trying to make some animation, right? And this is the thing that you would do. All right, after, and this is the whole thing, right? This is the whole program in a way. And after you break out of that loop, infinite loop, get the path, meaning construct the path, right? The path. Okay, and I don't know why I said and, by the way. I kind of confused me. And it kind of makes an assumption, to be honest with you. That's not 100. I test this program for lots of maps. However, it kind of makes an assumption. The assumption being is that, yeah, actually it's not an assumption. Anyway, when you get that node, the first entry of that open, and if that corresponds to end, that object is your, like, the final one, right? Is your end node. So path by IDs, meaning just give me the path and give me as, or indicate each node as their IDs, right? With their IDs. All right, while again this is like again infinite loop, right? And here first this is empty, right? This is empty, and at the end node's ID, okay, and then update that node, temp node we call, as its parent, meaning get the parent of that end node, right? And again write or record append to our array the ID of that, right? And then again go to the parent and get the ID, go to the parent, get the ID till we reach 1 ID number one. Of course, you can also write type equals 5, right? It kind of consider the case where your start node is located at ID number 1, right? And yeah, Let me change that. Let me change that, right? Okay. Now you can do that. Alright. So your start node doesn't need to be here. Doesn't need to be here. It can be here as well. Right? Okay. What I tried to explain was that after that, and because of the structure, just we started with the final node and dot 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 in the start node, right? However, change that. Change that. By the way, you know what? This is. I feel that I shouldn't, break that anyway. And just path ID, get the IDs on that path, and again plot it, right? Okay. So what are we looking at here? Okay, that's DFS. Okay, let's look at the DFS, and let me just get them, and this is the problem. And let's look at a little bit more sophisticated problem, right? All right, let's run it here. Okay, that was kind of good. And let's look at the DFS. Where is it? Okay, just Ctrl R to comment out and Ctrl T to comment in, I guess, right? And let's run that again here. Okay. So by the way, that only also indicates that it is the optimal path, right? Okay, let me close that. Let me close that. And let me use that. It's like 10, right? So maybe we should. Okay. By the way, we can just. It doesn't need to be right rectangle. All right, let's run that here. This is BFS, by the way, right? This is BFS. Okay. And let's look at the DFS. Ctrl R, Ctrl T. Go to the beginning. And let's look at that. By the way, I made a mistake. Actually, I mean, I'm sure that you realize that. I mean, it's kind of a mistake. It is random. It's random generate something. Random generate something, right? And whenever I run that, it will generate some other. Or is it? Okay, just let me try once more. Of course, totally, of course. It will generate random field or random map. So if you like to random generate, if you try to if you like MATLAB to generate random map, however, if you like to kind of keep that map as well, you would use that type of function RNG at the top of your I mean the line before the random, right? Maybe we will use randy in other innovative lines, and you like to use some other seed, and this is called seed, and I just written 111. You can just one right and a bunch of numbers. It doesn't signify anything, right? However, if I write 111 and you can write this, the field that you and I generate, they will be same. So that's it. Let's look at this. Okay. What is it? It is DFS, of course, right? And let's now we can compare BFS and DFS, right? Press Ctrl R and Ctrl T, and let's compare them. Okay. All right. So I guess this is it, right? And here it's like really heavily commented. And I will try to share that with you guys. So thanks for watching, and don't forget to subscribe. Okay, see you.